What if the deadliest things in space are not the ones we imagine, but the ones already waiting in silence? Not monsters, not invaders, just the ordinary laws of the universe, stripped of mercy. Beyond the thin, blue veil of Earth, the cosmos is not cruel in any human sense. It is simply indifferent, and that indifference can kill with astonishing speed. For most of history, human beings looked upward and saw promise. The night sky carried myths, direction, wonder. Later, it carried mathematics, telescopes, rockets, and the stubborn belief that distance could be overcome by intelligence. We learned to leave the ground. We built machines that could cross oceans of blackness. We sent fragile bodies into a place no body was ever meant to survive. Yet every step outward has revealed a difficult truth. Space is not just empty, it is active in its emptiness. It dries, freezes, burns, crushes, irradiates, confuses, infects, and tears apart. The hazards are not rare exceptions. They are the background condition of everything beyond our world. A floating drop of water, a grain of dust, a burst of sunlight, a fleck of paint moving faster than a bullet, each can become a question of life and death. This is the strange story at the heart of exploration. The more we reach toward the stars, the more clearly we understand the delicacy of being human. Our lungs, our blood, our memory, even the quiet rhythm of thought inside the brain, all depend on a narrow set of conditions that Earth has provided so generously we almost forget to notice them. And maybe that is where this journey begins. Not with triumph, but with humility. To go into space is to carry life into a realm that does not welcome it, and to ask whether curiosity is strong enough to endure the cost. It begins with a suit, a white shell against black infinity, bright as bone in the sunlight, humming softly with pumps, valves, and recycled breath. From a distance, it looks elegant, almost serene. But every seam in that suit is a negotiation with death. Remove it, and the body does not slowly surrender. It begins to fail almost at once. The first danger is not what movies taught us. A person exposed to the vacuum of space does not explode. The body holds together, but the pressure that protects blood and tissue disappears in an instant, and the balance that keeps life stable collapses. Air rushes from the lungs, moisture on the tongue and in the eyes begins to boil, not from heat, but from the sudden absence of pressure. Consciousness can fade in seconds. This is one of the most unsettling lessons of the space age. Life on Earth depends not only on oxygen, but on weightless, invisible pressure. We rarely think about it. We move through it as fish move through water, supported by something we cannot see. Only when it vanishes do we understand how completely it has been holding us together. Engineers know this intimately. Every spacecraft, every airlock, every visor latch and glove seal is built around one fragile truth. The human body is not made for openness on that scale. It is made for shelter, for atmosphere, for the soft restraint of a world that presses gently from all sides and asks nothing in return. And so the suit becomes more than equipment. It is a portable planet, a tiny promise of Earth, carried into a place where Earth does not exist. The mystery is not that space can kill so quickly. The mystery is that we learned to cross into it at all, wrapped in fabric and faith, trusting our survival to a few millimeters of design and a long chain of human care. Then there is the cold, or rather, the misunderstanding of cold. We imagine space as a frozen wasteland, a place where a human body would instantly turn to ice. But space does not behave like winter on Earth. There is no air to steal warmth from skin, no wind to cut through clothing, no weather in the familiar sense. The danger is stranger than that. In sunlight, an object can become intensely hot. In shadow, it can bleed heat away into darkness. The threat is not simply freezing, it is violent imbalance. A spacecraft crossing orbit moves between extremes with almost no softness in between. One side bakes in unfiltered sunlight, another drifts in deep cold. Metal expands, contracts, creaks. Systems must regulate not just comfort, but survival. Inside every vessel, temperature is an argument constantly being managed, a quiet engineering conversation against the surrounding void. For the human body, this instability carries a deeper lesson. We are creatures of moderation. Our organs do not ask for much, only consistency, a narrow range of warmth, a steady flow of fluids, a rhythm that holds. Earth, for all its storms and seasons, still protects that range with astonishing generosity. Space offers no such kindness. It gives brilliance and darkness, then leaves the body to solve the difference. There is something almost philosophical in that. We speak of the universe as though it were a destination, but it is also a mirror. It shows us how local our definition of normal really is. Warmth is local, breath is local, safety is local. What feels natural to us is, on a cosmic scale, a tiny exception. So when we look at a spacecraft drifting calmly above the world, we are really looking at a moving island of balance, a manufactured climate, a fragile pocket where the human story can continue for a few more hours, a few more months, perhaps someday a few more years. And the question beneath it all remains quietly astonishing. How far can a species travel when what keeps it alive is so narrow and the universe so wide? Look closely at the window of a spacecraft, and you may see nothing at all. No storm, no predator, no visible threat moving through the dark. And yet, outside that glass, danger can arrive in pieces too small for the eye to follow. A chip of metal, a grain of paint, a fragment from an old satellite broken years ago. In orbit, even the smallest object becomes a kind of bullet. Velocity changes. A bolt drifting through space at several miles per second carries a force out of proportion to its size. Something no larger than a seed can crack a visor, tear a panel, wound a machine built at enormous cost. Around Earth, humanity has left behind a scattered halo of its own past ambitions, discarded rocket parts, broken tools, shattered remnants of collisions, countless fragments circling the planet with no intention but tremendous power. There is a bitter irony in this. Some of the most dangerous things in space are things we made ourselves. The path outward is not only blocked by nature, it is cluttered by history. Our inventions do not simply vanish when their mission ends. They remain, they drift, they accumulate, and over time, they turn exploration into a landscape haunted by old decisions. For astronauts, this means living inside a constant calculation. Radar tracks, shielding layers, flight paths adjusted by a few cautious degrees. Every mission depends on knowing where the invisible is, or at least where it might be. The quiet of orbit is not peace. It is surveillance, vigilance, the discipline of moving through an environment shaped by both physics and memory. Perhaps that is why orbital debris feels larger than a technical problem. It carries a human metaphor. We are always surrounded by the remains of what we once built, once believed, once launched with confidence into the future. And sometimes those remains come back toward us at enormous speed, asking what responsibility survives after achievement. In that sense, space does not only test our courage, it tests whether wisdom can keep pace with ambition. But the most intimate danger in space does not always come from outside the spacecraft. Sometimes it travels in with the crew, hidden in the chemistry of their own cells. Beyond Earth's protective atmosphere and magnetic field, radiation moves through space with ancient patience. It comes from the sun in violent bursts and from far deeper sources in the galaxy, carrying enough energy to pass through metal, flesh, and memory alike. On Earth, we live under a shield so constant we rarely notice it. The air above us softens the blow. The planet's magnetic field bends charged particles away. In orbit and beyond, that shield grows thin or disappears altogether. An astronaut may feel nothing as radiation passes through the body, yet damage can begin quietly, molecule by molecule, strand by strand, in places no sensation can report. This is what makes radiation so haunting. It is not dramatic in the ordinary sense. No sound announces it. No visible wound appears at once. Instead, it introduces uncertainty into the future, a higher risk of cancer, possible harm to vision, stress on the nervous system, questions about what long journeys might do to thought, mood, and the delicate architecture of the brain. The danger is physical, but it is also temporal. It reaches forward in time. For explorers planning voyages to the Moon, to Mars, or farther still, radiation is more than a technical obstacle. It is a reminder that distance itself has a biological cost. The farther we travel from Earth, the more we leave behind not just home, but protection. We do not enter deep space unchanged. Deep space enters us. And so the dream of exploration becomes more complex, more human. It is not just about engines and maps. It is about what a body can endure and what a mind is willing to risk in exchange for wonder. The stars invite us outward, yes, but they also ask a difficult price. How much of ourselves are we prepared to place in the path of invisible fire, just to know what lies beyond the dark? And then there is the sun, the great giver of life, which in space can become a sudden agent of destruction. On Earth, sunlight arrives softened by layers of air, filtered, scattered, made gentle enough to warm skin and feed forests. But beyond that shelter, the sun is less familiar. It is brighter, harder, less forgiving. And sometimes it erupts. A solar flare or coronal mass ejection is not merely a flash in the sky. It is a storm of energy and charged particles hurled across space at extraordinary speed. Satellites can fail, electronics can glitch or die. Communication can fade into static. For astronauts caught outside strong shielding, the danger becomes immediate and personal. The same star that made life possible can, in the wrong moment, threaten it. There is something humbling in that reversal. We like to think of danger as distant, arriving from the unknown edges of the universe. But one of the greatest hazards in space is the object that has always been closest, the bright constant our ancestors trusted to mark day from night. Familiarity, it turns out, is not the same as safety. Even the most beloved forces in nature contain extremes we only partly understand. This is why space travel depends so deeply on prediction. Scientists watch the sun with anxious devotion, searching its surface for patterns, disturbances, hints of unrest. Missions are timed around temperament. Spacewalks become wagers placed against a star's mood. Our machines may be advanced, but in the presence of solar weather, they still reveal an older truth. Exploration is never pure control. It is always part knowledge, part humility, part listening. And perhaps that is the deeper meaning of these solar storms. They remind us that the universe is not arranged for our convenience, even when it has nurtured us. The same source can sustain and threaten, illuminate and blind. To travel outward is to accept that paradox. We do not leave Earth to conquer reality. We leave it to meet reality more fully and to discover how much courage it takes to stand in the light when the light itself can wound. Weightlessness sounds almost beautiful at first, a body freed from burden, a cup of water becoming a floating sphere, sleep without pressure on the spine, movement that looks less like walking than drifting through a dream. For astronauts, the first encounter with microgravity can feel playful, even miraculous. But the body is not fooled for long. Human beings are built in conversation with gravity. Bones strengthen because they are asked to bear weight. Muscles maintain themselves because they must resist the pull of Earth. Fluids settle where they should because down exists. Remove that constant, and the body begins to renegotiate itself. Muscles shrink, bones lose density, blood and other fluids shift upward, changing the pressure in the head and even the shape of the eyes. What feels like freedom becomes, over time, a slow unraveling of familiar balance. This is one of the strangest hazards of space. Not impact, not fire, not vacuum, but the absence of something so ordinary we barely notice it on Earth. Gravity is invisible, yet it writes itself into posture, circulation, strength, orientation, and instinct. It teaches the inner ear how to understand motion. It gives the body a map. In orbit, that map blurs. Astronauts exercise for hours not to become stronger, but to remain themselves. Treadmills, resistance machines, disciplined routines, all meant to remind the body of a force no longer present. Even then, the return to Earth can be disorienting. Standing becomes effort. Balance must be relearned. Home feels heavy. There is a quiet wisdom in that heaviness. We often speak of being weighed down, as though weight were only a burden. But some forms of weight are also belonging. Gravity binds oceans to shorelines, keeps forests rooted, holds the atmosphere close, and tells the body where it is. In its absence, we glimpse a profound truth. What anchors us may also be what allows us to endure. And so the question deepens. If humanity dreams of living far from Earth, can we truly leave gravity behind? Or must we find some new way to carry its memory with us? And still, even after vacuum, radiation, debris, and the slow erosion of the body, one of space travel's most difficult threats remains almost impossible to photograph. It lives in silence, repetition, and distance. It gathers not in the skin or the bones, but in the mind. A mission can be engineered with precision, yet the human interior remains less predictable. Space does not only test survival, it tests meaning. Inside a spacecraft, the days can begin to lose their edges. The same walls, the same voices, the same careful procedures repeated under artificial light, while Earth, if it is visible at all, hangs far away like a memory you cannot step back into. Isolation is not merely loneliness. It is a change in the texture of thought. Time can stretch. Small irritations can deepen. Fatigue can become emotional weather. Astronauts are trained for this with remarkable seriousness. Psychologists study group dynamics, sleep cycles, conflict patterns, attention, and mood. Crews rehearse not only emergencies, but coexistence. Because the danger is real, a strained conversation, a lapse in judgment, a mind worn thin by confinement can become operational risk, as surely as any mechanical failure. In deep space, there may be no quick return. No immediate rescue, no ordinary way to step outside and breathe. What makes this hazard so human is that it asks an uncomfortable question. How much of our stability depends on the subtle companionship of Earth? Not just gravity and air, but weather, trees, privacy, strangers, seasons, random sounds from an open street. The feeling that life is happening around us even when we are alone. Remove those things, and the mind begins to understand how social, sensory, and rooted it has always been. Perhaps that is why the psychological frontier matters so much. To travel farther, we must learn not only how to protect the body from space, but how to protect the self from emptiness. The deeper journey is not just across distance, it is through solitude, confinement, and the fragile architecture of consciousness. And that leaves us with a haunting thought. When we send humans into the dark, what exactly are we asking them to carry for the rest of us? It may seem surprising that one of the greatest threats in space is not always the vastness outside, but the complexity inside the machine meant to protect you. A spacecraft is often described as a vehicle, but that word is too simple. It is a sealed ecology, a breathing mechanism, a moving life support argument in which every system depends on another. Oxygen, water, temperature, waste, power, navigation, communication, fire suppression, carbon dioxide removal, all of it must keep working in concert. When one part falters, the danger can spread with quiet speed. On Earth, failure is buffered by abundance. If a room grows too warm, you open a window. If power fails, help is usually near. In space, there is no such surrounding generosity. Every reserve is counted. Every repair is constrained by distance, tools, training, and time. A clogged filter, a leaking valve, a software fault, a spark in the wrong compartment. None of these sound mythic. Yet in orbit or deep space, the ordinary becomes existential. This is what makes spacecraft accidents so haunting. They remind us that exploration does not only depend on bravery, it depends on maintenance, discipline, and the humble reliability of things built by human hands. Heroism often arrives not as a grand gesture, but as a checklist followed under pressure, a repair completed in tight quarters, and a crew staying calm while the machine around them begins to misbehave. There is also a philosophical unease in this dependence. The farther humans travel from Earth, the more life becomes mediated by systems we cannot individually control. Survival rests on expertise, distributed across engineers, designers, flight controllers, and the countless invisible people whose work holds the mission together. In space, independence is partly an illusion. We live because others thought ahead. And perhaps that is not a weakness, but a truth we are often reluctant to admit. Human survival has always been collective. Space simply makes that fact impossible to ignore. Out there, every breath becomes evidence that no one reaches the stars alone. There is another danger in space that feels almost philosophical before it becomes practical. Distance itself. Not just miles or kilometers, but delay. The farther a crew travels from Earth, the less immediate Earth becomes. A message takes longer to arrive. Guidance cannot come in real time. Rescue turns from possibility into abstraction. On a long enough journey, the crew must become their own first responders, their own interpreters of risk, their own final authority in the moment that matters. In low Earth orbit, help is still conceptually nearby. Mission control can answer quickly. Procedures can be updated in conversation. A return, while difficult, remains imaginable. But on the way to Mars, the relationship changes. Communication can lag by many minutes each way. A question asked in fear may sit unanswered in silence. A mechanical failure, a medical emergency, a navigation uncertainty, each unfolds inside that delay, like weather moving through a closed room. This changes the emotional architecture of exploration. Space is not only dangerous because it can harm the body, it is dangerous because it can separate action from reassurance. On Earth, we are surrounded by networks of response so constant we mistake them for certainty. Someone can be called. Someone can arrive. In deep space, those comforting assumptions begin to fall away, one by one. And yet there is something profound in this loneliness. It reveals a more mature version of courage. Not the confidence that someone will save you, but the steadiness to act when no immediate answer is coming. Future crews will need technical skill, yes, but also emotional endurance, patience, and a new kind of trust in one another. The farther they go, the more the human circle inside the spacecraft becomes its own small civilization. Perhaps that is the hidden cost of leaving home. Distance does not only widen the space between planets, it widens the space between question and reply, fear and comfort, danger and help. And in that widening, we discover something difficult and beautiful. How much of being human depends on the nearness of other humans, and how extraordinary it is when people carry that nearness with them into the unreachable dark. Then comes the danger that does not announce itself as danger at all. It looks like confidence. It sounds like routine. After enough successful launches, enough solved problems, enough elegant engineering, the extraordinary can begin to feel manageable. And that may be when space becomes most deceptive, not because it has changed, but because we have grown used to surviving it. Every era of exploration carries this temptation. Procedures become familiar. Risk becomes quantified. Catastrophe begins to seem less like a possibility than a statistic pushed safely into the margins. Yet space has a way of punishing complacency with unforgiving clarity. A missing seal, a misread sensor, a piece of foam, a line of code, a decision delayed by hierarchy or softened by optimism. Disasters are rarely born from a single dramatic mistake. More often, they gather quietly from small compromises that no one intended to become fatal. This is not merely an engineering lesson, it is a human one. We are creatures who normalize what we repeat. The mind protects itself by turning the improbable into the ordinary. That skill helps us live. But in extreme environments, it can also blind us. When danger becomes familiar, attention relaxes. We stop seeing the sharp edges of the world because our own success has made them feel dull. The history of spaceflight is filled with brilliance, but also with grief that has reshaped institutions. Tragedy has forced agencies, engineers, and nations to confront a painful truth. Knowledge does not eliminate vulnerability, it only changes its form. The more capable we become, the more subtle our blind spots may grow. And perhaps that is why the deepest wisdom in exploration is not fearlessness, but remembrance. To remember that nature does not honor our deadlines, that physics is not persuaded by pride, that each mission, no matter how advanced, still crosses into conditions where error can widen quickly into loss. In that sense, humility is not the opposite of ambition. It is what keeps ambition honest, and sometimes what keeps it alive. What, then, is the most dangerous thing in space? By this point, the answer resists simplicity. It is not only vacuum, or radiation, or speed, or fire. It is not only distance or failure or the quiet distortions of the mind. The danger is cumulative. Space is deadly because it layers its threats, because it offers no forgiving margin, because one weakness can invite another until survival depends on an unbroken chain of care. Imagine a mission far from Earth. A burst of solar activity raises radiation risk. The crew shelters in a cramped, protected compartment. Sleep is broken. Tension rises. A small equipment fault follows. Repairs consume power and attention. Communication with Earth is delayed. No single event is apocalyptic on its own. But together, they create a new environment. One in which human judgment, machine reliability, and physical endurance begin pressing against their limits at the same time. This is how danger often truly works, not as spectacle, but as accumulation. And yet there is something deeply revealing in that accumulation. It forces us to see survival not as a heroic moment, but as a continuous practice. The romance of exploration often lives in launch footage, in shining helmets, in distant horizons. The reality lives in systems thinking, emotional discipline, and the fragile success of many ordinary things going right at once. To remain alive in space is to participate in an endless act of balance. That may be why the story of space is also a story about maturity. As children, we are drawn to the stars because they seem infinite. As adults, we begin to understand the cost of approaching them. Wonder remains, but it becomes heavier, wiser, less naive. We do not stop reaching outward. We simply learn that reaching outward requires a deeper respect for limits. So perhaps the question changes. Not what in space could kill us, but what kind of species chooses to go anyway. A reckless one, perhaps, but also a reflective one. A species willing to measure danger carefully, to learn from loss, and to keep searching not because the universe is safe, but because meaning sometimes waits beyond safety's edge. By now, the darkness of space may seem overwhelming, a catalogue of hazards too vast for any fragile creature to face. And yet that is not the whole story. The same environment that threatens us has also taught us some of our clearest lessons about ourselves. It has shown us how thin our protections are, but also how extraordinary our cooperation can be. Every successful mission is a quiet rebuttal to despair. Think of what it means for a human being to look down at Earth from orbit. Continents without borders, storm systems turning in slow white spirals, city lights flickering along coastlines like thoughts made visible. From that height, the planet does not appear invincible. It appears delicate, a small illuminated shelter in a surrounding immensity. Many astronauts have returned carrying that impression not as an abstraction, but as a changed way of seeing home. Perhaps this is the hidden gift inside the danger. Space strips away our illusions of separateness. It reminds us that life is local, rare, and dependent on conditions so specific they feel almost miraculous. The air we argue beneath, the gravity we complain about, the magnetic shield we never notice, the oceans, the soil, the ordinary afternoon light, all of it belongs to a narrow envelope of survival suspended in darkness. To leave Earth is to understand Earth better. This does not erase the risks. The vacuum will remain indifferent. Radiation will continue crossing the void. Machines will fail. Human judgment will always be imperfect, but knowledge changes the meaning of fear. It turns panic into preparation, vulnerability into design, isolation into partnership. What once seemed like an impossible frontier becomes, slowly, a place where wisdom can travel alongside courage. And maybe that is why the story matters. Not because space is trying to kill us, but because in facing what can kill us, we discover what we most value preserving: breath, memory, trust, home. The universe does not promise that we belong in it, but the human response has never depended on permission. It has depended on wonder, and on the stubborn hope that understanding danger is one way of learning how to live more fully in its presence. So we arrive at the end of the question, and perhaps at the beginning of another. Everything in space that could kill us is in some sense a reminder of what life requires: pressure, warmth, shielding, gravity, companionship, time without too much delay between fear and answer. We tend to notice these things only when they are threatened. Space, with its vast indifference, makes them visible by taking them away. That is why the story of cosmic danger is not only a story about death, it is also a story about value. The void teaches us the worth of atmosphere. Radiation teaches us the blessing of a protected sky. Isolation teaches us how deeply the mind depends on other minds. Mechanical fragility teaches us that survival is collective, built from trust, extending across disciplines, continents, and generations. Even debris circling Earth becomes a moral lesson, showing that what we leave behind can shape the future long after our triumph has faded. In that way, space becomes more than a frontier. It becomes a mirror held up to the human condition. We are a species, both resilient and breakable, audacious and dependent, capable of crossing immense distances while still needing the simplest things: air in the lungs, steadiness in the body, calm in the mind, care from one another. The farther we travel, the more clearly we see that vulnerability is not a flaw in the story. It is the story. And still, we will go. Not because the universe has made room for us, but because curiosity is one of the ways human beings answer uncertainty. We cross deserts, oceans, and now darkness itself for the same reason: to understand where we are, what we can endure, and what kind of wisdom must grow alongside our reach. So perhaps the final truth is this: space can kill us in 1,000 ways, but in learning that, we also learn why Earth matters, why one another matter, and why the future will depend not only on how bravely we travel into the unknown, but on how carefully we remember what keeps us alive.